Okay, so good afternoon. I hope you all enjoyed your lunch today. And welcome to the talk, to this university talk on the JAX-RS and JPA newest features. I'm going to do the first 90 minutes, and then after that, Sean Smith will cover the JPA advancements. My name is Jan Algermissen. I am from Germany, Hamburg, working as a consultant, mostly in the REST space. Right now, since the last 2 years, I enjoy the luxury of actually working full-time as a REST consultant, so I'm very happy. What I have as additional information, I will put on my blog after the talk. It might be the end of the week, but I think it's very useful to have the couple of links you need and maybe a description how to use the latest JAX-RS developments in an enterprise Java container. And that's not so easy, so I try to describe that, and afterwards you can look it up at the blog. So actually, if you came to this talk due to the abstract I've written, then I owe you an apology, because I wanted to put this whole thing in a context that has more enterprise relevance, where you have services that talk together, and it just didn't work out, because then you have to have so much additional information to share that you cannot really concentrate on the features. So this will really just be a walkthrough through the latest developments. And since it's kind of fragmented, because it's all the tiny additional points and they are not very closely related, I suggest that we make this, or if you have questions, you can just raise your hand. If I see them, I will then, or you can, where's the microphone? Is there a microphone? Oh, he's not listening. Where was the microphone? Where's the microphone you talked about? No, for the questions. Ah, okay. So you can just come to the microphone and we can handle the questions in between, so they are right on the topic where we are in the talk. So the information on the web about the JAX-RS 2.0 features is actually very sparse, and I found it kind of hard to find out how to use those and to find more background information, because it's very different from JAX-RS 1.1, where many people actually blogged about it before. So much of this might actually be pretty new to you. One thing we are going to cover, and it's one of the most wanted features, is the client API. It's really not that new if you know the other client APIs, the proprietary ones. But the thing really is that it's now standardized. Then we have filters and interceptors, which are also part of like the REST Easy and Jersey developments. So some of this will be familiar to some of you. We have a very, very interesting support for asynchronous request handling and response generation. We have support for Hypermedia for generating links. Very small feature, but very powerful if you want to use it in the IDE. And there's a very, very tiny addition, but I think it will turn out to be one of the most useful ones. That's resource context. We talk about this in the end. So the client API, I said that it's really just basically a consolidation of the APIs that existed before, and the benefit you have from it now that it's standardized and it's going to be part of Java EE7, so you will have this API available in every Java EE7 container, and you don't need to juggle around with additional classes and the corresponding dependencies. The first thing you're going to need to actually do anything in terms of issuing a client request is get hold of a client, and you do this by getting a client object from a client factory. It might be that that you have additional client factories for other clients, just like the Apache HTTP client. After that, you're going to need to register the, I'm sorry, but I actually don't see the presenter screen here, which is kind of confusing. So if you want any providers to be active during your requests from that client, you need to register them explicitly. There's no runtime at the client side that will actually look up providers and apply them to your requests. This will only happen if you add them to this client via the register function. You can also add features, we come to that later, and you can supply whatever properties you need for customizing or controlling or configuring the providers you registered. The first thing you need when making a web request is a web target. Web target is what Jersey used to call web resource or resource. And this is basically an encapsulation of the target URI where your request is going to. It's a fluent API, so you're actually asking the client to give you a target, a web target, and you can then, on that web target, call other methods to refine the web target, and every time you will get a new instance. So this customer's web target is really a totally new object compared to the CRM web target we created before. You have all kinds of methods like metrics parameters, query parameters on the web targets. So, it's kind of working familiar to the server-side APIs. And this would actually add a query parameter. Now, sometimes you have one and the same thing, and you want to build it in a row. And for this, you obviously need URI templates. Web targets support URI templates. So if you have something like this, you have a car URI and you need to create many of them, you can invoke the car resolve template method and in turn create web targets with this URI parameter resolved. And again, it will always create a new web target. So the web target instance is actually immutable. So when we have the web target, we have created this. This is how you're actually going to issue a request. You call the request method on the web target, and this is where you supply what's going into the accept header of the HTTP request. It's always this kind of pattern. You may also supply a media type constant there, but you can also supply it as a string. And then you invoke one of the HTTP methods, in this case get, and you get back a normal response, which is the same response object that is right now also used on the server side. From this response object, you can normally just extract parameters, extract the status, extract links, there's support for link in it, and of course also the response entity, which is where if you know the server side of JAX-RS, it just works the same way. So you supply the type of the object you want the entity to be turned into, and the client side runtime will invoke an appropriate message body reader and turn the customer the entity stream received from the server into a customer object. You can, of course, also send data, which is done by, so if you consider this and we have a customer and we want to send this customer representation to the server, you invoke a post method, and into that post method, we have to supply some information, what the media type is actually going to be that is put in our request data. And for this, there's this new entity class, And the entity class is a wrapper, or is what actually allows the client side to select the appropriate message body writer when streaming out the customer. So the general pattern would be to wrap to combine the object you want to send with the media type in which you want to send it, and then put this into the entity.entity static method. Now, within the entity class, there's also support for the standard or for the provided JAX-B message body readers and message body writers, and this is here the XML, JSON, text, and HTML entity methods, which you can invoke without explicitly writing, turn this into XML or JSON or whatever. And there's also support for form. So you could take arbitrary key value pairs and turn them into an HTTP, application X www form URL encoded. So sometimes you are doing one and the same thing in turn, and it's creating web targets comes at a cost. So there is a So if you do it like this, you have to create the web target inside the loop every time over and over again, and maybe you have headers in there, and all those functions or all those methods, if you remember, create a new web target object every time. So in this loop, you are actually creating 1, 2, 3 web target objects. You can work around this if you just use a single one, and there's a new concept called invocation. And an invocation is basically a prepared request. And what you do is you build up the request right until the end, but you don't invoke the request method. And then you can take such a request, such an invocation, and invoke it over and over again. This can also be a useful feature if you want to separate the concerns of generating requests, maybe in a GUI, or maybe in an environment where some thread is actually creating requests and putting them somewhere, and another thread is picking them up and just invoking them. And the invoker of the request doesn't need to know how it's going to be invoked. It's just invoking it, and it's yielding the response intended by the provider of the invocation. Is that clear? It's kind of a funny concept, I think, but it might turn out to be very, very powerful. One thing about this is, if you think about SQL queries, how they can be parameterized, this is something you unfortunately cannot do with an invocation. So you cannot build an invocation, put parameters in there, and just invoke it over and over again, supplying new parameters. In the API, however, there is an internal class called Builder, called Invocation Builder, which we can use to achieve this kind of behavior. So we can, instead of building the invocation all the way up to the end, we can just stop before we actually say build get or build post. And what we end up with is an invocation builder. And then we could use this invocation builder inside a loop and supply an additional header, which is probably changing every time. As you can see here, suppose we are doing a polling, but we want to make this a conditional request. So every time we want to supply the e-tag that we actually right now hold for the polled resource. This also works with sending data, and there it's probably much more interesting because the calling the post method is more costly than the get methods because we supply the data to be sent. So you can do the same, just create a builder, and then when you invoke the invocation builder in the loop, you supply the entity with the post invocation. Then there's a new annotation, which is called URI, and it allows you to create web targets by annotating just a web target instance. You can do this by supplying an absolute HTTP URI, and you can do it by supplying a relative URI. And then when it's used within the context of a JAX-RS runtime, the relative URI will be resolved using the application path configured for that runtime. Now, you can also supply templated values, templated URIs, but only if you are inside a resource class. Because what JAX-RS will, what the runtime will do is it will resolve the parameters in the URI template you provided based on the parameters on the resource class. So this is probably kind of unintuitive. So summing up the client API, we have 4 core new classes. That's client, web target, invocation builder, and invocation. If you want providers to be invoked, they must be registered. This is not a change to the APIs, to the proprietary APIs that exist so far. We have a fluent API, which is on each invocation causing new objects. So you could get immutable objects, invocation and invocation builder and web target are all immutable. Then to prepare the request to fill the accept header, we have the request method. To provide an entity, a request entity, you need the entity class. And we have a potentially very powerful separation of concerns using the invocation and invocation builder. So if you have questions now about the client API, it's probably a good time to ask, but we can also do this in the end, of course. Oh, and we had the add URI annotation. So the next thing is filters. And this appears to be a very easy concept, but it's actually not. But let's start with a very simple canonical filter. What happens here is when a request or response flows through the JAX-RS chains, the filter will be invoked at the appropriate invocation points, and this is, of course, client response, client request, container response, container request. Within each of those messages, you are supplied a request context, and you find the methods to access request and response information as you would expect it. Like you find on the container side, you find the annotations, you find the entity, you find the request header, and this kind of stuff. Now, this is the flow a request is going through on the server side. So what you have here is a first invocation point where filters are executed, and this is before the request matching to a resource method. That means or when JAX-RS is handling a request, what it does first, in the first step, is trying to find the correct resource based on the annotations on the resource methods, and on the other hand, based on the content type and accept header the client has been sending with the HTTP request. And this is happening in the pre-matching phase. Then request matching happens, and then you get another filter chain after the request matching, where you have potentially access to different information, because right here, the runtime already knows which resource class and resource method will be invoked in the next step. Then you have the message invocation. We are ignoring the MBR side for now. It will throw into the application, and then the response is streamed out. It goes again through a response filter chain, where again any registered filters are invoked, and then the response is streamed to the client. On the client side, the pre-matching phase is obviously not there, so it goes through request filters before the request is actually sent out to the server. The server handles the request comes back, and also here for now we are ignoring the MBR and MBW chains. An example filter would be a logging filter. Here you can see what kind of information you can access. You get the request method, you get the request URI, you get access to a multi-valued map to access the HTTP string headers. And this is something you could do if you wanted to just log the request. But you could obviously also change the request method or the request URI or the string headers. So if you wanted to, you could change the request method so that the JAX-RS runtime actually ends up with the, oh, now we are on the client side here. Client request context. Kind of lost, okay. But assume it's on the server side, so you could alter the method and change the behavior of the JAX-RS runtime. This is an example where you can, how you change a header. So it's also flowing through, and you can invoke get headers, put single, and can set a cache control header if you desire to do so. This would be an example for a filter that is in this pre-matching phase, and you do this by annotating the filter with pre-matching. I actually forgot to say that obviously for the JAX-RS runtime to find the filter, you have to annotate it with provider. But I guess that's implicitly understood. So if you also annotate it with pre-matching, it will be invoked in this pre-matching phase. And what you can do here, for example, is you can rewrite the URI. So you have access to the URI info based on the request context, and you could supply a new URI. And what you can do with this is you can hook a filter into the chain before the request matching is actually done by the runtime. So you get the ability to modify the outcome of that content negotiation process. An example that's in the spec, I think, it's that you can, if you find a header that has this X HTTP method set, if you, for example, want to send a delete, but you have a client that cannot send a delete, and you send the delete as a post, but you supply a header saying X HTTP method equals delete to inform the server that the intended method is a delete, then you could rewrite in this filter, you could react on the HTTP header and exchange the post method with a delete method. That's the kind of stuff you can do in the pre-matching filter. What you can also do is you can abort the filter chain, so any filter can directly skip any further processing and produce a response. For example, if you are not authenticated, or if you find the user is not authenticated because it supplied some invalid authentication token, you can send a 401 directly and skip any further processing by the server. This is how you could implement this, where you would actually get the URI of a login form, and if you find the authentication token is invalid, you redirect to the login form. So far, we have not talked about the entity in the request and response. And this is where the API, to me, was at first very, very unnatural, partly depending or partly due to the name, because you have those methods here to access the entity stream, and I'm missing the next slide, so I cannot see what's coming. Sorry. So what you can do is you can obtain the stream where the data is going to flow through, and you can supply a new stream to the runtime. So you can actually hook something in. What you cannot do is you cannot actually see the data. There is no entity flowing through the filter. You just have access to the stream object and can supply a filter stream, for example. So if we would use this to implement a compression filter, where we say, okay, when we send a response from the server, we want to gzip this. The canonical way to do this would be like this. So you obtain the old stream with getEntityStream, and then you create an output stream zipping filter based or wrapping around the old one, and set it back. So later on, all the full entity stream will actually flow through the zipping stream, providing a zipped version of the entity. Now, the problem with this is that you, at some point, after zipping, you want to invoke the finish method of the zipping stream. This is not like finalized, it's not the destructor, but it's just closing the zipping process. So you need to invoke this method, and you cannot do this here because inside your filter there has never been any data sent. Everything you are doing here is just supplying this filter stream to be invoked later on in the chain. So this is not going to work. And I found this unintuitive because this thing is called a filter, but it's actually never filtering anything. You don't see the data in the filters. And this is because when you have the filter chain here, it ends, the filters are done, and only then there's a potential invocation of the message body writer chain, which will then cause the entity data to flow through your filter or through the filter stream you provided. And this is why there's a second concept, which is called interceptors. So in addition to the filters, you have interceptors, and those really, let me show it here, and those really are invoked in those message body reader and message body writer chains. This is where the interceptors will be invoked if the chains are actually invoked altogether. So going back here, this is how an interceptor looks. Very similar to a filter, with the one difference that the interceptors are the same, the reader and writer interceptor are the same on the client and server side. So we only get two extension points here. And what they do is they don't sit in the chain, but they wrap around the invocation of the write to and read from methods of the message body reader and message body writer. So the difference to the filter is really that they are seeing the invocation of the message body reader before and afterwards. and which means that, as you can see here now, we get access to the, or we still hold the read or the write context after the invocation of the message body reader and message body writer. This is what you don't have in the filters.
What else? There are some controls still missing that are not in the JavaFX API that you may know from Swing and for example, or tree table.
So let's try a second time the entity compression, with this time with an interceptor. So what you would have to do, you would have to implement a writer interceptor. In this writer interceptor, you have an around write to method, which will be called when a message body reader, a message body writer is invoked. You can do the same thing here. You get the output stream. It's not called entity stream here, it's output stream, but it's the same concept. You get hold of the stream. You register your output stream filter, in this case a gzip filter, and restore the stream or set the new stream so the invocation of the write to method will actually flow through your filter instead of just the original output stream. Then you need to call context.proceed to get to the next filter in the chain and eventually to the message body reader, because it wraps around. We need to actively further the processing. And when this proceed returns, then you get a chance to do additional work on your output stream. And in which case we can now here call the finish. And if we want to, it's good practice, but it's not necessary, just restore the old stream. Here again, the data is not flowing through your interceptor, but you are merely providing a filter that is going to be hooked in the output stream. So you are also not seeing the data, but you can supply a filter stream that is in turn seeing the data. But in this, there is actually a very subtle problem, which is not easy to see. Because what you are doing here is you are messing with the entity stream in a way that is going around, or it's working around the JAX-RS runtime. For example, all the matching and all the processing is done based on the HTTP headers, accept and content type and whatever. And when we change the stream here, we are changing the semantics, or we would actually have to, sorry, I take that back. When you invoke the gzipping here, what happens is that you change the content length, for example. But the content length header has potentially already been set by the runtime, so it's already gone. You cannot set a header here because the header is already out. And you actually only here maybe know how large your entity is, or you only here know that you want to unset the content length header. So this was discovered, and behind this is a mismatch, an architectural mismatch of the old JAX-RS architecture and the filter concept. And I'm trying to explain that briefly. It's not so easy. So the runtime, the JAX-RS runtime, will at some point ask the message body writer for the getSize method. And if this writer doesn't return a -1, if it returns -1, it will default to chunked encoding, so there won't be a content length header. But if the message body writer actually supplies a content length, this will be placed into the content length header. Then the response filters are called, and then afterwards the message body writer write to is called. And if this method is actually, the interceptors wrap around, and if the interceptors change the content length, then the content length, the new content length, will not match the content length header supplied by the message body writer in the first place. And you cannot resolve that because the message body writer doesn't actually know and has no way of knowing that the request is possibly going through an interceptor, especially not if you are maybe using a third-party library that you just hook into your runtime, and which you didn't author yourself. So there might be gzipping interceptors at work. You have message body writers that supply a content length, and there is no way to detect this problem. So what we had to do is we had to deprecate get size on the message body writer. This is actually in the spec now. So it says, like, as of JAX-RS 2.0, this method has been deprecated. It needs to, existing message body writers are advised to return a -1. And the JAX-RS runtimes have to be changed to completely ignore this, the return value of the get size method, because it's an architecturally not solvable problem. It's a mismatch in the two concepts. I wonder if anybody actually used get size, but some people might, so we had to deprecate it. So is this problem solved? No, it's actually not solved, because there is a lot more going on in this HTTP method semantic and the stream, because when you gzip the content you are sending, how would the client ever know that it's gzipped? So what you need to do, in addition, is you need to, first of all, this is read from. Why is this read from? Sorry. Let me do this with the write to. So this is the gzip example we had before. And what the first thing you would have to do is you would have to actually ask the client or look at the HTTP request headers whether the client is capable of processing a gzipped encoding. You cannot just throw it in there, because HTTP has this mechanism which is content negotiation relevant, that the client should say accept encoding if it actually is capable of decoding gzipped responses. But even more important is you have to supply a content encoding header, otherwise you produce an invalid HTTP message. And this is actually more complicated than it looks, because the value of the content encoding is not just gzip, but it's an ordered set of tokens which record all the applied encodings. So you would have to get this value and put your gzip value in the right place and restore the header. This is what I think it's sort of really complicated stuff. It's pro stuff, and you should think twice if you are going to mess with the entity stream in an interceptor. I would rather suggest just using it for auditing purposes, monitoring purposes, but it can be very tricky to actually change the entity stream. Here's one more example what you can also do with interceptors. This is a digital signature example where what you do is you take the whole stream and you buffer it, and so you block it. And when you have buffered it, you calculate a signature, or you calculate a signature value on it, and you put that signature value into the HTTP headers, and then send the whole thing to the client. So what's happening here is really that since we are blocking, we are sucking up the whole data that's flowing through the stream in our byte array stream, and this causes the runtime to not send out the headers. So when the proceed returns here, we have still access to the HTTP headers. They have not been streamed because there was no data in the actual output stream. So we could, at this point, set additional headers and then take our buffer and stream the whole buffer. I'm pretty sure there are quite some interesting cases what you also can do with this, but it's just starting, so It will take some time, I guess. So to sum up this filters and interceptors section, you get 7 extension points. That's 4 extension points for the filters, where you have this request response on the client side, request response on the server side. You get the 1 because you have the additional pre-matching on the server side, and you get the 2 extension points in the invocations of the message body writer and message body reader on client and server side. So those 7 points is where you can actually register your filters to, or interceptors. We get pre-matching filters, which you can use to change the information that's going into the content negotiation algorithm of the JAX-RS runtime. Filters are completed before the entity is actually streamed. The stream is not flowing through neither. It's not flowing through interceptors and also not flowing through filters. I think be careful with handling, with changing the stream. And the get size has been deprecated. Questions so far? Or should I pause a second? Because I didn't find this so easy when I looked into it. So. Oh, get size is now ignored. So since we have those 2 concepts, filters and interceptors, it's really, if you look at the message signatures you can override, they are very, very similar. In the context you get, the things you have access to in the context are similar, and you might ask yourself a question, why do I have the filters at all? Why do I have the interceptors at all in addition to the filters? Why can't I do everything with filters and have 2 less API constructs? So here's the differences. Interceptors can actually write to the output stream before the data is flowing, right before the data is flowing, and right after it. They have a hold on the stream object after the processing. That's what we saw in right after calling the proceed. One very important thing is that the interceptor is seeing the user object type. So while in a filter, the entity type is just object, in an interceptor, you know the type that has been provided to the message body writer or message body reader write to or read from method. So if you think about building a client-side cache, for example, and in that cache you would store information not in the form of the HTTP response you saw, but maybe in an already unmarshaled object form. So you are not storing the customer entity data, but you are storing in the cache the customer object. Then you can only retrieve such a thing in an interceptor, because only there you know that the user actually requested the entity to be turned into a customer object. You won't see that in a filter. That's one of the biggest differences. And interceptors are only invoked if the entity is actually requested. So if the message body reader, if the user doesn't pull out the object, doesn't request the entity stream to be turned into an object, then the interceptor won't be invoked at all. because the whole chain won't be invoked. So filters and interceptors there can be multiple in each extension point, and we need some sort of mechanism to order the invocation of them. And this is called priorities or binding priorities. So what you can do is you can annotate a filter with a binding priority, and this the runtime will sort the filters by binding priority and invoke them in this order. What we have in the API now standardized is authentication, authorization, header decorator, entity coder, and user, and those are really just integer values. They don't have any meaning to the runtime. They are just used to sort the filters. So when you look at the flow here, you see that the ordering takes place everywhere where those three figures are standing, and then you have a reversed order in the client response chain. So the filters are then invoked in reverse order to get the same processing semantics as in the request chain. And the same is on the server side, where in the response phase the filters are also invoked in the reverse order of the priorities. What is kind of strange is that the ordering applies to every chain in turn. So if you have the pre-matching phase has a chain, and after the matching phase has a chain, and the ordering applies to both chains but individually. So you could actually have a filter decorated with header decorator, which is in the binding ordering after the authentication, but if you apply this to a pre-matching filter, it will actually be invoked first because it's in this chain and the other filter is in the other chain. So this is kind of maybe tricky concept. So applying per chain, ordering by binding priorities. Yeah.
If two filters have the same binding priority, is there a way to influence which one goes?
No, it's like implementation defined. Yeah. I'm still looking for a way to actually define your own values, but I guess you just define your own annotation or just value, or just put the value in the annotation. But then you would have to know the actual values, and they are opaque from that point of view. Now, so far we have implied that the filters are being applied just everywhere. And this is probably not what you want. So the normal behavior is a filter that's seen by the JAX-RS runtime is applied to any request, to any response. If you don't want that, then you have a mechanism called name binding, which is used to bind certain filters to certain resources. So you can define your own annotation, in this case locked, and then you go and annotate the filter, and at the same time annotate exactly those classes or resources where you want the filter to be invoked. You can also annotate the class, then it's inherited by the methods. So if you would put the locked on the resource class, every of the methods would actually be the filter would be applied to every of the methods. So this is actually a very powerful concept because you can pass data from the annotations into the filter. So if you imagine you have a cacheable annotation, and in that annotation you provide as a value the cache control header you want to be set. Then you could annotate your resource method with cacheable, and then supply your cache control. And in the filter you also annotate with cacheable. You could then look for the cacheable annotation, extract that, and use the value that has been particularly applied to this resource method in here to set the caching information. So you could use this filter to have different caching properties on different resource methods, but using the same annotation. So now, is anybody here that's actually supplying JAX-RS providers as libraries? Because this concept is really, really powerful if you are a provider of software to be just placed into a JAX-RS implementation to supply some additional functionality. On the server side, this is called dynamic feature. And this is also actually very easy, but I find it kind of hard to understand at first. So a dynamic feature must implement the configure method. So you just write your own class, implement dynamic feature, and this is the configure method. And the configure method will be called from the runtime for each resource class and also for each resource method during the startup phase. And the information, which class and method it is in this call been applied to, is passed in using the resource info parameter. So this thing allows you, and nothing more, but it allows you to understand which resource class and resource method you are now in this call dealing with. There might be other calls later for every resource method, but right here it's just this one. And then what you need is sort of a large if cascade where you test what is the resource I'm seeing now. And then you can apply all kinds of metrics. For example, see if this is an instance of a particular resource class and if it has a particular annotations. But you can test basically for anything that you can extract as information from class or method arguments. So you could write your own annotations, place them, or write your own annotations, allow a user of your library to annotate its resource methods and libraries with that annotation, and in your dynamic feature you configure the whole thing based on where those annotations have been supplied. So in the first thing you had a logging filter, and then in the second you had an audit filter. And I think this is very, very powerful, but it needs to be explored. But you can do very, very powerful things with this, especially in terms of separation of concerns to decouple your implementations. So there was a difference in the two invocations, because in the one register call, we supplied a class, a type, and in the second one, we supplied an instance. And you can actually do both. And when you supply a class, then the JAX-RS runtime is advised to use the class or to use the singleton instance of the provider it has already created, with all the dependency injection working and everything. And if you supply an instance, you can supply your own dedicated instance, but you don't get dependency injection. So this new logging filter won't be managed by the runtime. But you have the benefit that you can actually pass in parameters or supply, create your own singleton, do special stuff with it, and supply it. Binding on the client side is a little different, of course, because here a provider is only seen by the runtime if you explicitly register it using the register method on any of those 4 client-side API constructs we had. That was client, web target, invocation builder, and invocation. They all can be configured this way. And the same here, I can provide types, and I can provide my own instances. And also that way build dynamic features, or what? No, I have to say something else first. So what happens here is, I said before that the 4 constructs are immutable. So if you call webTarget.matrix parameter, you get back a new web target. You don't get back a changed web target, you get back a new web target. This is different with the register method. If you call register, you get back the same object with the changed configuration. And if you configure your client and then create a web target using that client, you are inheriting the configuration and can further refine it. Because when the web target is created from a client, for example, there will be made a deep copy of the configuration data. So you are not changing the configuration of the client, but you get your own dedicated configuration object. And it's a fluent API, so you can actually chain those calls together very elegantly. There's also a way to bundle things on the client side. They are not called dynamic feature, they are just called feature. So if suppose you wanted to provide a client-side library, caching library with the necessary providers, you could implement a client cache feature that needs to implement the feature interface. And there's also a configure method which is being called. So in the last line here, if you register your feature, if you say client.register client cache feature, this is when the above configuration method will be called, and then you can control which kind of providers you intend to be applied to this web target or invocation builder or invocation. Summing this up. So we have named binding on the server side, dynamic features on the server side. You got the register method on both sides to apply things to configurable elements. You get the difference between registering types and registering instances, and this brings us to the asynchronous API features. Any questions on the binding? No. This is something that's also been waited for a long time, and we have now support for asynchronous request handling on the server side. And one of the backgrounds for this is that you actually want to be capable, or if you have long-running request processing, then you don't want to block your HTTP worker sets by having the worker, the HTTP worker, working on producing the whatever, maybe potentially blocking data to actually create the response. So what you sometimes would like to do is to place threads that are working on different concepts in different thread pools, which you can now do, because if you consider this resource method, which is serving requests to something very large, for example, a PDF document that needs to be generated, whatever, you have a parameter here called async response, and you annotate it with the @suspended annotation. And what this gives you is a response, it's an object representing the current or the response, and you can pass this object around. So you can actually create a new thread, pass this asynchronous response into the new thread, and have that thread handle the response processing, and your HTTP worker thread can go back directly and process the next request. What you do inside this worker thread is actually create resume at some point with the normal response object or entity object, and this will cause the HTTP response chain to be invoked and the response be sent to the client. An interesting aspect is the combination with the EJB 3.1 asynchronous annotation, because here you don't need to explicitly create a new thread because the container is doing this for you anyway. So you can apply this pattern where you annotate with @asynchronous, pass in the suspended asynchronous response, and then you don't need the additional thread creation code. It's being done in the background for you anyway. What you also have is timeouts and callbacks. I'm not going into the details too much, but of course you have all the things that apply to asynchronous processing. So you can register a callout, you set a callout, a timeout, register a timeout handler that will be called when the timeout hits. What you can also do, you can reset the timeout, so when the timeout hits, you are not outside the response, you can still set a new timeout again. You can supply callbacks that are called when the connection is terminated and those kinds of things. So what you can also do with this is, of course, implementing push architectures. Are there any Comet front-end developers here that are interested in this? Because what the async response allows you to do is it allows you to park the response for a longer time. And you could, what happens here is that every request for this stock Apple is actually just placed into a queue to wait. And clients can then implement long polling, and the server just fills up the queue with the waiting polling clients, and the clients have to leave the connection open, of course. If the queue is full, you can just return with a retry after header, this kind of things. Then you could implement a notify method that observes some whatever events. And when an event hits, the notify method is called, and then you can take all the parked responses, the async responses in the queue, and just answer them in turn. It's probably not the best way to do it, but it's just a canonical example of what you can do. This is really something, if you are into long polling things, that the JAX-RS runtime couldn't do before and can handle very nicely now. This is what the client could do. You could implement a poll invocation. Normally this would probably be AJAX, but for the sake of things, I did it in JAX-RS here. So you implement a polling invocation or create a polling invocation, and then you keep polling, and like every time the poll returns, it might be blocking for a longer time, but every time it returns, you just fire up the new request in turn waiting. So, of course, we have asynchronous requests in the client too. That means I can invoke an invocation asynchronously. The code will return after the invocation, and a new thread will handle the invocation in parallel. So what I could do, I don't know if I actually, no, I didn't. So I have to walk this through here, you through this. How am I going to do that? So suppose you are having some sort of calendar data widget that you want to hook to an HTTP request. You could do it like this. You just go to the calendar resource, build an asynchronous request with the async in the first line, the async method. Do the get and then supply the callback that is to be called when the request is actually coming back. And in this callback, you could connect the calendar widget with coming back calendar data and update the widget in the background. And you can do this in parallel, of course. Also nothing very new or complicated, but it's just not been there previously. So with async, you get the better thread pooling if you want to. You can park responses, and they are really objects you can pass around in your server implementation. You could implement long polling with this. You get all sorts of callbacks and timeouts also on the client side. On the client, you get parallel requests, so you could implement something we know from every browser to use a JAX-RS client to download 20 images in parallel. And also on the client side, you get callbacks or futures, so you can either supply callbacks or invoke methods that return you a future object, which you can then poll to see if the request has already been performed. So the next is linking. So far it has been kind of difficult to create URIs to other JAX-RS resources you implemented, because you essentially you have to put in the path information you have into the place where you create the links, and this is bad because you're duplicating information. You have the path information in the path annotation on the one hand, and you have it at the place where you produce the link to. So if you refactor the one side, you get problems, or you have to keep track on which link generation places you actually have to adjust as well. What we now have is, what's this? Suppose you have this entity, this entry resource from a block or whatever, annotated with path annotation, with URI template, and what you have here is you have a method that's not annotated with path, and you have one that's annotated with path, so you have a sub-resource that takes another path as the initial path information. This is important because what you get is you get two new methods on URI builder. One is to create a URI from a resource method. And this will be like the URI you see in the resource path annotation. And here you can do the same on a resource method that has a path annotation where you can call a URI builder from method. And in this case, you have to supply the method name as a string. Obviously, it doesn't work in any other way. The first version will be stable across refactorings. So if you change the name of your resource class, then your IDE, for example, will change the name of the resource class in the from method invocation as well. But it won't work, obviously, in the case of the from method example, because the get comments is just a string, and that's opaque to the IDE. So this is still a case where you have to be kind of careful. If you change the method name in one place, it won't change automatically here. You can then build that URI in the normal way, supplying data for the URI template variable, and this would yield a relative URI relative to the JAX-RS application path. In this case, entry is 42 comments. So the URI created with this will always be relative. You get a new link class with an internal class link builder, which basically works the same way. You can supply a resource class or resource class and method, and you also supply the link relation, in this case edit or comments. And this will create you in the same way link objects with the pre-filled information based on the URI builder internally and the link relation value. So you could build that, extract a header value, and this would yield a string suitable for putting it into an HTTP link header. And this is really something where I wonder how useful this API is in practice, because the link you get here is not really usable, because it's not relative to the application context, but it's relative to the application path, which is like /resources or whatever you configured. And the entries 42 here is actually not resolvable. And either I have not understood the API properly, but I cannot really see a case to put this link anywhere without actually prepending the URI base information, which would render the whole link object creation kind of meaningless in the first place. So what I think is the runtime should actually take the complete URI and supply that, and save me the trouble of prepending it. You can use the URI builder, or you can use this Hypermedia support, of course, not only inside resource classes. You could do it in any provider. For example, here is a container response filter that adds to every response a service link and just has a private member that's been built from the service class path annotation. So this is just to show that this is not limited to use in resource classes or resource methods. So linking from resource or methods. In the method case, you have to remember that this won't be stable across refactorings. I like the pure resource class approach better. And this is, I think, a pending decision whether the links in that way are really useful. So the last topic is actually a very tiny one, but also very powerful, because so far, if you are familiar with the sub-resource locator concept, I will explain that. So you have in JAX-RS 1.1 the sub-resource, the concept of sub-resource locators. So you can have a resource method that returns an object, and if the resource method is not annotated with an HTTP method, it will just defer the matching to the returned class. So here is no resource, here is no get, no post, no nothing. So the runtime will try to apply the matching to the entry resource instance that's coming back. The problem with this is that new entry resource creates an instance that is not managed by the JAX-RS runtime, so you don't get any dependency injection in there. You have to supply the ID explicitly. You cannot have any annotation inside that's pulling the ID from, or where the runtime is providing the ID via an annotation. And this is where this new concept of resource context comes in JAX-RS 2.0. And what you can do now is you have a new injectable class resource context. And the resource context has two methods. One is called init resource, that allows you to initialize a new instance. So this init resource will take your instance and make it managed by the JAX-RS runtime, and also apply this managed instance to the current request context. So everything you get in the request class outside that call, you will have available in terms of dependency injection inside that new instance. So I could, in my entry resource now, for example, inject an HTTP headers instance to get access to the current HTTP headers. This is something that was not possible before. Interestingly, since so what we saw previously is the original use case, but since this is an injectable class, it can be injected with add context anywhere. So I could take any provider and inject the current resource context in there. And then inside a filter, for example, I could create my own instances managed by the JAX-RS runtime. This is the second line here with gadget. You see that I'm inside the filter creating a new gadget and make this managed by the JAX-RS runtime, and I can even provide my own constructor arguments to customize the gadget instance I want to create. There's another method right above that, that's rc.getResource, to which you can supply a class, and the runtime will then instantiate a managed instance of that class. So this is how your widget and gadget might look like. Inside of them, you can now use the request injection capabilities of JAX-RS to access the current request information. And this saves you from the trouble of supplying it in the constructor. And if you take this a step further, you could also do this, for example, in an interceptor. And I don't know yet if this is useful, but it looks useful for me, so I'm supplying this. I don't know where this leads yet, but feel free to have your own ideas. So in an interceptor, I can do the same thing. I can inject resource context, and then when I'm creating this entity filter stream object that I'm hooking into the stream, I can actually make that manage too. And then have inside my filter output stream access to the current request information, which might be useful when I'm working on the stream that's flowing through. So when I override in the output stream filter, for example, the normal write method, inside that method I have all the current request information available. One thing to note is, of course, the whole injection of resource context doesn't work in a pre-matching filter because it's just returning null. There is nothing there to inject because we don't know this at this point. So you get DI for sub-resource locators. You get DI for any instance, for example, in your stream filters, and that's the talk. So I'm not going to sum this up again. I just put it here. Questions so far? We have got 10 minutes left. I didn't expect that to be so close. I think it's a lot of little things that potentially are very powerful, that can be kind of confusing because they really work at tiny edges of the runtime, and I think there are pretty interesting things you can do with it, actually. The framework support for this is scheduled for Jersey and REST Easy in like the first half of 2013. That's mostly due to the official certification being done at that point. Both implement large quantities of the new API already. Apache CFX is planned, so they definitely want to do it, but it's not scheduled yet, and RESTlet has this on the agenda for some time, for 3.0, but it's totally unscheduled. So thank you. I'm going to stay here for 8 minutes for questions, or you can take a break. Yeah.
Is there any menu or something which describes how to upgrade from, let's say, Jersey 1.1 to the new Jersey version?
Okay, so the question was whether there is any menu, how to actually try out the new concepts or to upgrade.
Yeah, how to upgrade it.
It's kind of hard because it interferes with the existing variations of Jersey you have in for example, Glassfish. So it's very hard to take a 3.0 or a 3.x Glassfish and just put in the new JAX-RS APIs. That doesn't really work. You get confusion everywhere. What I'm doing is I'm downloading the latest Glassfish, and they are also always a couple of days behind the snapshot Jersey 2.0. And then it's sort of the latest. So you get a delay of some days, but that works pretty well. But it's still rather buggy in some places, so it's kind of hard to understand whether you are doing a mistake or whether the runtime is just handling not properly what you are doing.
Are there many code changes required, or is it just upgrading when it works?
What do you mean, coaching's required?
Code changes.
Code changes. No, I don't think there would be any code change except for the get size. I don't know anybody who would actually implement get size to return anything else than -1, and we didn't know, we didn't either on the list, so don't expect any changes, no. On the client API, of course, because you have they are very close, closely related, the Jersey client and the new JAX-RS client, but of course it's different. Yeah. I'm sorry, I couldn't hear it.
Do you know if someone is working on the old filter for JAX-RS?
Well, there is interest in general. So Bill Berkey from the Rest Easy is interested in doing this, and there has also been this. I don't know if you heard that. What's his name? The lead of OAuth that left OAuth, Aaron, but I don't know the last name off the top of my head. So what he did is he started a new project called OZ, where he basically wants to redo what he thinks is proper, and there has been some interest by the Rest Easy folks to actually follow that development and implement that in JAX-RS. Or implement that in Rest Easy, I think. But this is sort of a week old or something, so. Okay, then thank you. And if you have further questions, don't hesitate to just send me a message or something. I will be glad to answer.